All right, so this is problem number 26 from the sprint round of event 12226. So let's get started with reading it out. What is the units digit of the sum of the first 2022 perfect squares? Now, before we get started with this problem, let me just clarify for everyone what a perfect square is. So a perfect square is what you get when you multiply a whole number by itself. So a whole number times itself will give you a perfect square. I'll give you some examples. So if you take the whole number 1 times 1, then you get 1. So 1 is a perfect square. 2 times 2 is 4. So 4 is also a perfect square. And same thing with 3 times 3, which is equal to 9, and so on. So these are examples of perfect squares. And we're supposed to evaluate the sum of the first 2022 perfect squares, and then it asks for us to take the last digit of that. So anytime I see an enormous number like this, I know that I'm not going to actually be adding up 2022 perfect squares. That's just impossible to do in the amount of time that I have for this problem. So if I see a number that's this big, I know that there has to be a shortcut somewhere. Now, the first step that I like to do whenever I see a problem that's this massive is I'm going to start smaller. And instead of finding the sum of the first 2022 perfect squares, I'm going to start out smaller. Let's just do the first 10. And then we'll see if we can find a pattern later. So I'm going to write out the first 10 perfect squares. Now, the way that I'm writing this is I'm using this 2 that's floating above the numbers. So this means 1 times 1, and that means 2 times 2 and 3 times 3. So just to be clear, that's the way that I'm writing these perfect squares. So we have 1 squared plus 2 squared, 3 squared, 4 squared, all the way up to 10 squared. All right, and I know what these numbers are. I have them memorized, so I'm just going to write them out really quickly. All right, that's still not a very good sum that to calculate. It's still going to be kind of big, but I noticed that the question is only asking for the last digit, the units digit. So when I'm evaluating this, I don't have to worry about the tens digit or the hundreds digit. I only need to look at what the last digit is of each of these numbers. So that's what I'm writing here. So I can get away with just taking the last digit of each of these and then adding them up. And then once you add them up, the sum is going to be a lot nicer. So this whole thing on the bottom is equal to 10 plus 10 plus 10 plus 10 plus 5. So that's equal to 45. And again, the units digit of that is 5. So what this tells me is that if I add up the first 10 perfect squares, the last digit of that is going to be 5. All right, so we got that problem down. Let's try to make this a little bit bigger. So what if I wanted to find the sum of the first 20 perfect squares? If I wanted to do that, I'd have to also add on the next 10 perfect squares. So all of these numbers plus the ones I've already added. So these numbers are going to be a lot bigger. So I'm hoping I can find a pattern before I have to calculate all of this, because eventually these numbers are going to be just absolutely ginormous. So 11 squared is 121, 12 squared is 144, and 13 squared is 169, 14 squared is 196. And I'm going to stop there because I don't really like memorizing my perfect squares. But also, I think maybe we can see a pattern already. See, the units digit of these perfect squares are 1, 4, 9, and 6. And if I look at what I already had, the first 4 units digits were 1, 4, 9, and 6. So I think 15 squared is going to continue the pattern, and I think it's going to also have a units digit of 5. So we can try calculating this out, and this gives us 25, so 7. This gives us 225. So the units digit of 15 squared is actually 5. So this kind of shows my pattern, or my intuition about the pattern was right. It seems like the units digits for these numbers from 11 to 20 are the same as the units digits from 1 to 10. And if you want to know why exactly this is true, you can just take a look at what we did in the long multiplication. See, all of these digits here in the tens place and the hundreds place don't affect the last digit. In fact, the only time that I did a calculation that did something in the last digit was this 5 times 5. See, 5 times 5 gave me 25. So again, this shows that if I want to find the last digit of these perfect squares, I only need to look at the last digit of that number. So 16 squared is going to have the same units digit as 6 squared, and 17 squared will have the same units digit as 7 squared. So this is a really neat pattern, and we can really use this to our advantage to help scale up to this very large number of 2022. So let's carry on then. 16 squared is going to also end in a 6. 17 squared will end in a 9. 8 squared ends in a 4. And 9 squared ends in a 1. So this is just continuing the pattern that I already noticed. And if we add this up, we get the same thing as before. So 45. And again, just notice how if we add up the perfect squares from 11 squared to 20 squared, we're going to have a units digit of 5. So now let's try answering the actual question of 2022 perfect squares. So again, this is going to be a very large number, but with this pattern, I think we can do it. So again, if I added up the numbers, the perfect squares from 1 squared to 10 squared, that gives me a units digit of 5. And if I take the sum from 11 squared all the way to 20 squared, that also has a units digit of 5. And if we use the same pattern as before, this also has a units digit of 5. So I don't think I have to keep writing this. I don't want to keep writing this because we have way too many rows of this. So at the end, what this is going to look like is we have all of these rows of 10 perfect squares. They all have a units digit of 5 when you add them together. So the last row that I have to write is 2011 squared all the way up to 2020 squared. So this also has a units digit of 5. The last two numbers that I have to add are 2021 squared plus 2022 squared. And so right here, we have the first 2022 perfect squares. And all that's left for us to do is to simplify everything right here, and we'll be almost done. So because all of these rows have a units digit of 5, let's just figure out how many rows there are. And then we can simply just multiply by that number of rows. So if you see here, we have a 1, 2, 3, and a 4 here. So this kind of serves as a way to count the number of rows we have. So I have the first row having a 1 in the tens place here. And over here, now I have 202. So this means I have 202 rows of 5s. So the total sum of all of these 5s, if I add them together, is 5 times 202. And again, remember, we're only looking at the units digit of these numbers. So what this really means is that the sum of perfect squares from 1 squared all the way to 20 squared ends in a 0. So that's great news for us, because now all we need to look at are the last two numbers. So 2021 squared, that is the same units digit as 1 squared. So 2021 squared ends in a 1, and 2022 squared ends in a 4. So together, this adds up to 5. And if you add this with our 0 from before, this means that all of these numbers from 1 squared to 2022 squared have a units digit of 5. And so that is our final answer.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.